Right, so this is a worked example on the topic of correlation and regression. This particular one is looking at the temperature on a mountain. So quick look at the question. A meteorologist believes that there is a relationship between the height above sea level, that's H meters, and the air temperature, T degrees Celsius. Data is collected at the same time from 9 different places on the same mountain. The data is summarized in the table below. So here we've got a collection of pairs. So for every height, there is a temperature. So 1400 meters, it's 3 degrees, and so on. So we've got these 1, 2, 3, 4, 5, 6, 7, 8, 9 different data pairs. Okay, and what we're interested in is understanding the relationship between these two. Is there a correlation between them, or is there a correlation that is in any way significant, and so on. So the thing that we do with these is basically we can calculate the correlation, and we can also calculate the regression line as a linear function, a straight line. And this goes back to what you probably remember from doing it at earlier stages, where you do a scatter graph and draw a line of best fit. So that regression line is that line of best fit, except it's calculated rather more scientifically. Okay, so to do that, what we would do is we get our calculator, and if we go through these functions, I'm not going to do it here in this video. Menu 6, so we gets this option up here. If we then choose 2, see, this is the linear. If we wanted to model the data with a quadratic or a log function, there are options there for doing that, but we're going to do we're just doing a linear. So we're going to enter the data in there. We can carry on down, putting more data items down here using the arrow keys and the corresponding Y value. Then we go and choose option, and if we then choose our regression calc, option 4 here, then it comes up with this little set of values here. Might just mention as a reminder, this H is what's called the explanatory variable, and the T is the response variable. The terminology is carefully chosen so as not to imply that one causes the other. In fact, this correlation is not equal to causation. Is a little bit of a clarion call from statisticians, and certainly from the examiners, and you know, that's something that actually may well be explicitly asked to actually, you know, it could be worked in somehow, and you've got to demonstrate that you understand that one is not actually causing the other. There may be other things, underlying things, which are causing both. So it's a question of correlation rather than cause. Okay, so it goes on. Well, you might have noticed that there's no part A to this, and the reason for that is this is actually an old question, and it dates back to the days when you had to sort of do these calculations by hand virtually. So you had some kind of unnecessary calculations to do. I mean, unnecessary in the sense now that the calculator does it all for you. So we go straight into question B, calculate the product moment correlation coefficient for this data. Well, we've done that as a result of using our calculator. We look at this, and the correlation coefficient is this result R here, which is R equals, provide the minus in there, minus 0.952 to 3 decimal places. So that is it's a strong negative correlation. Okay, so it's 3 decimal places. State whether or not your value supports the use of regression equation to predict the air temperature at different heights on this mountain. Okay, well, it is a small sample. It is only 9 data points or data pairs, but this is a strong negative correlation. And now we can do a significance test. And if we go back to a previous video, you'll notice we used a table of values to determine whether or not a correlation coefficient is significant for a particular data sample size. So without referring back to that, I think we could probably see that it is. And in actual fact, if you were to check the table, you would see that it's significant, even if we use quite a sort of stringent significance level. If our criteria are quite harsh. So yes, so it's small sample but high negative correlation, and yes, it will support the use of a regression line. That regression line is given to us by these first two parameters, a and b. You can actually see they've given us a hint here that y equals a plus bx. Well, our y is the response variable. The x is the explanatory variable. We've actually got t instead of y, and we've got h instead of x. So if we plug those parameters into our regression line, we get we get this here. And then interpret the value of b. Well, b is the rate of change of t with respect to h. Last part I've not included here. Estimate the difference in air temperature between a height of 500 meters and a height of 1,000 meters. Well, we simply have to just put those values into our equation there, and we can work those out and find the difference. Okay, so that is basically it. So hopefully that has been useful, and see you next time.